Hello, everyone. Welcome back. Or welcome if you're just joining us for session 7. So it's now 2 o'clock, so we are going to go ahead and kick off the next session. So session 7 is SAS to Python conversion introduction to SAS to Py tool. So before we get started, I do want to just go over a couple of administrative items. So as our speakers present, please do remember to stay muted to minimize distractions and interruptions. And if you do have a question, please put it in our Zoom chat feature. That way our presenters have a record of them. And if we don't get to all questions, we can keep track of them and get those to our presenters to answer after the fact and publish them to our Q&A and portal. And I'll read them at the end if time permits during our Q&A portion. So with that, let's go ahead and move over to our session speaker, who's going to be Ashley Miller. So I will turn things over to him now.
Great, thanks, Julia. Thanks everyone for joining. My name is Ashley Miller. I am an architect on the AIM project. AIM is artificial intelligence through machine learned modeling. It's the name of the project. But specifically as part of this project, we're going to be talking about SAS2PY. And we can move to the next slide and introduce Parv. Parv, if you want to introduce yourself.
Sure, thank you, Ashley. So, hey everyone, my name is Parv Joshi, and I'm a data scientist with the AIM project. Yeah, I think that's a good introduction. So proceed.
Great, thanks, Parv. So on this is the agenda for today. We're going to do quick introductions, a couple more names you'll see here on the next slide. Then I'm going to go through a presentation of SAS2PY just to set a little context. And then Parv is going to walk us through a live demonstration of SAS2PY. And hopefully we'll have some time for Q&A at the end of this session. So next. So here are some of the other key people on the SAS2PY project working under AIM. The project owner is Nana Adu from CMS, of course. Bhavani from Index Analytics is the project manager for AIM. And we have quite a few people here that from Explore Digits that are actually SAS migration experts. So they know SAS, they know Python, PySpark, and of course they know the SAS2PY tool, which we'll be talking about. And then Fedor Filinov is responsible for the AWS infrastructure where SAS2PY is actually running. Next. So why SAS2PY? As you all are aware, SAS2PY is being decommissioned, and this is part of an initiative to modernize and improve data management. And so all organizations, CCSQ and non-CCSQ organizations, will be moving away from SAS and SAS2PY to tools such as Databricks and others. And the reason for this transition, you can see here, to enhance performance scalability, and reduce costs, and move to an open source platform that provides more flexibility as well. And SAS2PY is a developer's tool, which is going to help CMS convert their existing SAS code to Python and either Pandas or PySpark. We'll talk a little bit more about that in the upcoming slides. So that's why SAS2PY is being made available to CCSQ. Next. So when you talk about converting from one programming language to another, in this case SAS to Python, there's many different issues with doing this manual conversion. One is there's really, the code has been around a while, and I imagine some of the SAS code y'all are working with has been around for decades, and maybe even going back 30 years or more. SAS has been around for a very long time. So there's maybe a lack of documentation for some of this older SAS code. It's been used, but maybe not maintained over a long period of time. And then as people leave CMS, they retire, there's this loss of institutional knowledge as well. So that's some of the challenges. When you're doing the actual conversion or migration, you need resources that know both SAS and Python. And doing manual conversion is very time consuming and error prone. So tools like SAS2PY can automate that process and really give you a big head start on that migration. Next. So SAS2PY is a tool that does provide this automatic conversion of SAS to open source Python. And when you do your conversion, you have several options of the environment to where you're converting it to. So Python is a programming language, and there's many different libraries that come along with Python that are used in the data analytics world. And then you need a place to execute that Python as well. So those execution environments could be an environment like Databricks. So, but SAS2PY as a developer's tool is going to provide this automated analysis of your SAS code. It's going to provide an automated conversion. So truly a one-click convert, and then you specify your environment. Am I going to convert from Python, from SAS to Python PySpark or Python Pandas, Python Databricks, Python Snowflake, right? You specify where the end environment is going to be. There's many different integrations. So SAS2PY has many different integrations. You can see some of them here with GitHub integration, Visual Studio VS Code, and there's also a generative AI piece that's being built into SAS2PY as well. It's essentially a private large language model that allows you to ask questions about your code. Okay, next. So here we talk a little bit more about some of these integrations, but I want to point out a couple of different things here. So you can see on the right-hand side some of the different platforms that we will generate code for. But I want to talk a little bit about a couple of these last bullets here, PEP 257 and PEP 8. So PEP are Python enhancement proposals, PEP, Python enhancement proposals, and then they have a digit associated with them. So PEP 8, for example, is a proposal for properly formatted Python code so that you end up with consistent Python code that is readable and maintainable going forward. So SAS2PY generates PEP 8 compliant code. PEP 257 has to do with doc strings, or essentially documenting your code. So SAS2PY also generates PEP 257 doc strings for all your generated code. So not only does it generate this code for you, it generates code that is meant to be readable and maintainable following current Python standards. Next. Next slide, please. So we have two SAS deployments within CMS today, one at CMS CCSQ, where we did a successful pilot. We worked with Derek and the QDAS team, converted SAS to Python PySpark, and ran that code, converted the code, ran the code, did a data match, make sure that the SAS results were 100% a match to the results produced by the Python PySpark code. We're actually in the deployment is actually in progress right now for end user access. So we actually have an AWS environment where this is being stood up and will be made available to the CCSQ team very soon. We're looking for a December launch for this. We're also working with CMS OIT and working with end users. In this case, the deployment model's a little bit different. For CCSQ, we're actually putting the tool in the developer's hands. You can do the conversion yourselves. With CMS OIT, we're working with different groups where we will Explore Digits will actually be doing the conversion and then working with them for actually getting that code into production. There's been many other deployments outside of CMS as well. So this is a well-proven tool that where it's been deployed successfully with banks, insurance companies, and other large organizations. Millions of lines of SAS code has been converted to Python with this tool. So a well-proven tool. Next, please. So I'm not going to go through all these bullets here, but I'll just let you take a moment and look at all the different supported macros and data steps. So this is not a tool that's just taking a little bit of your SAS code. It's not like a Chat GPT. This code was designed from the ground up to convert SAS to Python. And so many macros and data steps are supported within SAS2PY. And next, I think we have a list of the procs that are supported as well. Okay, and we'll go on to next. So one of the things the tool provides are some really nice analytics around your source code, around the SAS source code. So the first thing that happens is we'll do an analysis. The tool will do an analysis of the SAS code that you have, and you'll get some very nice metrics around, how many lines of code exist, what are the different procs that are in use, what are the different data steps that are in use. And when Parv goes into the demo a little bit later, we'll be looking at this in more detail. But the idea is that when you're doing your migration from SAS to Python, you want to make sure you understand your SAS code and what is your SAS, especially we talked about that lack of institutional knowledge. So if the person who wrote this original SAS code is not available anymore and you're trying to understand it, you're going to get these nice metrics around your SAS code. Not just metrics, but I think we have on the next slide, we have one of the diagrams that we produce as well. So this is showing actually data lineage. So how is the data actually flowing through my system? So if we've uploaded, let's say maybe a dozen different SAS modules that are all have it, that these modules have interdependencies around certain data sets. So we can actually look at the data lineage and how the data flows through the system as well. So this is part of the analysis phase that SAS2PY does. Again, helping you understand your SAS code, how the data flows through the system as you go into your conversion process. Next slide, please. So there's a full code editor built into SAS2PY. We mentioned we integrate in with VS Code and other IDEs as well. And not only do you have, here we're actually showing a screenshot of looking at your SAS code and the generated Python PySpark code side by side, so that you can see the SAS code and what exactly was produced for the Python code as well. So you can see this information side by side. Now, the interesting thing is on that previous slide, when we were showing the data lineage and how the data flowed through the different SAS modules, you can actually click on those blocks in the data lineage module and get directly to your code from there as well. So as you're following the data flow through the system, you don't have to go, oh, okay, well, which module was that in, and go find it in your file browser and all. So it's very easy to navigate within the SAS2PY environment. If you're looking at certain data flows, you want to see what transformation is happening within this particular block. You click on the code, click on the block, and you're taken directly to the code where that transformation is happening. So we provide some very nice navigation features as well. Next slide, please. We also have a large language model, a chat with providing Chat GPT like functionality, where you can go in and use natural language and ask about your code as well. So you could ask about a particular code block and say, just describe, what is this code block doing? Describe it in natural language. You can ask it, you can put in some SAS code and have it convert it to Python. If you just want to do a little block of code, it can do those kinds of things for you as well. So this is a large language model that is integrated in, we call it Ask AI. And this is a private LLM. So none of the information, we're not going out to ChatGPT, in other words. So none of the information that you use with Ask AI actually leaves the network here. So it is a secure environment, a self-contained large language model. Next slide. So there is a strategy associated when you're doing your migration. So we talked a little bit about the analysis phase. So understanding what the current SAS code looks like, what it's doing, what are your data sources, what are your data sinks, or what are the downstream consumers of your data. Then there's the code conversion step in the second block from the left. So this is where you actually convert your SAS code to Python code. And this truly is, like I mentioned, a one-click. Really, both the analysis and the code conversions are really just one click. You're going to get your analysis, do another click, you're going to get your code conversion. And then you get into the validation phase. So this is probably where you're going to spend the majority of your time, making sure that the code, making sure that the data results from SAS match the data outputs from your converted code. And so we have a tool called Data Match that assists with this validation process. And then going further, actually putting this into operation, looking at what integration steps with your current environment and putting it into operation. So while the code conversion is done by the tool, the analysis and conversion and the validation, there is more to it than just doing that, right? You've got to get it integrated into your environment and making sure that it is operational in the new environment. Next slide. So let's talk a little bit about the actual CCSQ deployment. So SAS2PY is currently being deployed in an ATO'd AWS account. And so we actually have this up and running today. It's currently in the process of being integrated with HARP Okta for authentication. The plan is that if you have a SAS via HARP role today, you won't need to do anything. You'll automatically have access to the SAS2PY tool. So while we have SAS2PY installed and running in AWS, we're working on this integration piece. Once this is made available to the CCSQ folks in CCSQ, then you'll be able to access the tool and upload your SAS code and analyze and convert that SAS code on your own. So the idea is to put this tool in your hands and make it available for you to use and start your SAS migration. Once you upload your SAS code, you analyze and convert your SAS code. Now you're going to take your you're going to download your converted code, this Python PySpark code, and take it over to an execution environment like Databricks and actually run it over there where PySpark, the Python PySpark can actually be executed in that environment. So that's in a nutshell, the CCSQ deployment that's currently in process. And next slide. So I'm just going to touch on this briefly on each of these numbered items. And this is really the workflow that you'll be going through when you go through the migration. So step number one is actually the SAS code analysis. So you take your SAS code, put it in the SAS2PY tool, and do your SAS code analysis. Step number two is actually doing the conversion. And if your code converts 100%, then you're ready to take it over to the execution environment. If it converts less than 100%, there might be some manual code remediation that needs to be done. Also, if you're working with a very large data set, let's say you're working with a data set that's in the tens of gigabytes, you might want to take a smaller subset of that data to do some unit testing to make sure that that data works correctly rather than waiting for an hour or longer for your full data set to run. So you might do some unit testing with a smaller subset of your data. That's what's going on in step number three. So step number four, you're executing your code. And then step number five is the data match utility, where you're taking the SAS result files and the data match utility is helping you compare that to the output of the PySpark run. So that's step number five. And you get the results of data match. And if you have 100%, then your code is executing correctly. If it's less than 100%, you're going to be going back to step number three. So you can see this can be a bit of an iterative process. Do any code remediation in step number three to make sure that that your data results are going to match. And so you're in that iterative loop now. until you get your 100% data match. And then step number 6 is optimization. So there's some things that you might want to do in terms of optimization. If you're using SAS2PY files, you might want to convert those to Parquet. Parquet files are better suited to run in a PySpark environment for multiple reasons. I won't get into those here, but it is an optimization. You also might want to do some code optimizations as well in step number 6. So that is sort of the general workflow when we talk about a SAS to Python migration. Next slide, please. I think that might be. So from an implementation standpoint, so our team is going to be your partner throughout your SAS migration. Our responsibility is to install and maintain the SAS2PY application, make sure it's available for you to use. We'll be providing some product training and, of course, technical support for the tool itself, but also for SAS migration. So like I said, our team has experience with SAS and Python as well as the tool, and we can provide technical support as you go about the different phases, including the code refactoring and remediation, optimizations, maybe helping with PySpark execution if there's issues there, and of course the data verification using the data match tool. So that's our team is here to help you with these steps. And next slide. Okay, I think we're going to turn it over to Parv now for a live demonstration.
Okay, sounds good. I can stop screen sharing at this point if that works.
Yep, sounds good. Hey, so do you see my screen?
Yep, looks good.
Yep, awesome. So let's get started. So this is the SAS2PY Studio I have installed, and there are several different functionalities in here, which I'll be showing you. So at first, this is just an overview of the projects we have. So we can create a new project and then add SAS files to it. And then it's like a different project for a different user case or something like that. So you can just add a project in here, give it a name, give it a description, and add users to different projects. That way you can do like a multitasking thing where, you know, multiple people are involved. So this one also gives you some of the information about this, about how many of the files are processed and things like that. And if I do a view, it gives a bit more information based on what's been happening. But we can also do the same thing in here, which is the file manager. So ideally, this is where you would come to create projects and upload your SAS files in order to convert them. So add project, it's again the same method in here. And once a project has been created, let's say I created a defaults folder, and in this one, we will have a lot of folders, which is used internally by the tool. And raw is going to be the folder within the project where you actually come and upload the SAS files. So it's just a new file upload and a simple drag and drop. We also have integration with VS Code and Jupyter, so you can actually pull it directly from a GitHub repository as well. But you can also like add SAS files directly, or maybe have subdirectories. Say like if I have a folder with multiple SAS files in them, you can upload the folder directly as well, instead of uploading each file one by one. And you actually can do the conversion and the analysis of these files as well. So if I select any file and I choose the options in here, there's like an option of analyze folder, or if it's a file, you can analyze the file. And if I just do an analyze folder, it will analyze all the files at once. So that is super helpful, and it gives you some of those metrics which Ashley showed in his presentation. So this is where you upload the SAS files, and once you have actually uploaded the files, analyze them, you can go ahead and convert them. And once the conversion is done, you can see it in the output folder here. So we will see an example of that as well. So this is how you navigate through all the file systems in the tool, and the same file systems are there in the Jupyter version of it as well. So it's the same directory projects, and you have the same files. Like if I go to demo, so there's like a raw folder in here, there's an output folder in here. So you can do that pretty conveniently. And once you've done the analysis, you can actually look at some of the project metrics. So if I choose defaults in here, so it'll show you all the metrics about the default projects. There's multiple SAS files involved in here, and it shows how many of them are processed, how many lines of code are there, how many errors were there in converting it to Python, and things like that. And we also have this metrics showing you like how many files are processed, how many errors are there, and we have like by lines of code and by number of code blocks. And basically, this is just some information for you to like understand your project better. There's also like a tracking of what step you're currently at, like how many files have you analyzed, how many you have converted, how many are validated, and things like that. And it'll show you like a percentage on your progress there. And we also have some tabular data in here, which is basically the same thing, but it's split by the SAS files in your particular project. So it'll show you the lines of code and things like that. For each file, there's a complexity calculation that goes on that takes into account like what kind of functions are being used and how big those are. So that calculates like the complexity of your code. And it shows you like the total number of blocks, how many were converted, how many were failed, and things like that. And you can actually view them for each file as well in the file metrics tab. So if I go up, I can choose default, or maybe let's choose a different project. I can use example3.sas. It shows you how many code blocks were failed in this one, how many were passed, and things like that. There's also a bar chart that shows you like the different kinds of functions being used in this particular file and how many code blocks are there. We also have like an area chart for the same, and you can change the number of like process blocks to like number of failed blocks, and it shows you like okay, there was a one proc means code block that failed to convert, and there was one proc summary. So this one is really helpful to understand your data and what's actually going on before you actually dive deep into the conversion and start validating them. So we also have this thing which Ashley also showed. So this one gives you a percentage. So this is by lines of code, and it gives you like what percentage of the code is a proc sort and what percentage of it is a proc import and things like that. And if you updated a file, it will show you like the version of it and when it was last updated. It also shows you like an upstream or input output things. If I change to a different file, maybe you'll be able to see like different, yes, these are input data sets to this folder. So if there are any output ones, it'll show it here. Upstream is basically different SAS files on which this current chosen file is dependent on, so you can understand interdependencies in there. So, and we also have the tabular data in here. So this one is for each code block for a particular file. It gives you a complexity, lines of code, and things like that for each block. So if there are multiple proc compares, then it will have like multiple process blocks and things like that. So this one is also downloadable, so it's like an CSV export, which I can do. And there's also a pre-checks option, which is actually giving you more information on the data being used in this particular file. So there's a column for a data table name, and then it gives you like the directories for them, and it specifies whether it's a source or target, which is like input or output. And the system is based as it's being created using like a data step or something, and file is something you're importing. So this one checks out for the CSV thing. And yeah, it basically helps you understand what the data looks like and where it's stored and things like that. So it gives you like full analysis on how your code is actually working. So let's actually jump into the converter. So for the converter, you have to like select a particular project and then choose a particular file. This shows you the lineage, which Ashley had shown in his presentation. So some of these are all actually code blocks. So in this particular file, all the code blocks will be like a particular node. And if they're independent code blocks, then they will be alone. But if there's like interdependencies, we'll have like these arrows in here. And if I click on a particular block here, it shows you like the interdependencies. So the green ones are like the one are basically the blocks you need to run before running this particular selected block. And let's choose, and the blue ones are actually the ones you use after you run after the selected block. So it gives you like dependencies on code blocks and how to run them. And there's also a lot of information. So if I click on this top icon here, it gives you some information. So there's some summary on the version history and the details what the block does and things like that. And there is also inputs and outputs that are being shown. So these are tables being used in this particular file. And we also have like the start line and end line of this code block and how many lines of code it takes, what percentage of the code is covered in this particular block. And basically, yeah, the same information as before. And just a quick note that these metrics do not actually require importing the data to this. So the tool actually parses through the code and identifies like the data being used in it, what's the schema and what the data name is. And based on that, it's basically giving you these metrics. So you are actually not going to share the code with the tool. You're not sharing the data with the tool. Only the code would be sufficient to gather these metrics. And the third option in here is code. So if you have converted the code, you will see like the converted code on the right side, but usually this usually appears after the conversion is done. And I'm going to show you like an example of how that's done. So this one gives you a side-by-side view of this particular block. You can also do a full code editor where you can see the whole thing at once. So I'll be showing you that as well. There's also a docstring option. So this gives you like a template for like a comment to specify what the particular function does. So you can basically add in things in here. And if it's something simple, it'll directly do it for you. And we also have code similarity. So it actually looks for similar code in different files across like the same project. And this thing is really helpful because let's say like if there are some minor like remediations needed in your code for it to run, or maybe you change some part of the code because you preferred a certain way of doing it, then you don't have to keep doing it again and again. You can basically pull the changes you made in a similar code block for a different file and put it in here directly. So this one helps a lot, and you can actually change the threshold. So currently it's set to 90. So if I reduce, the number of similar blocks increased from 8 to 12. So you can play around with this, and it's pretty easy to actually do this. And doing like a preview also gives you a preview of the other code block that is similar. And lastly, like for each block, we have like an Ask AI option. So this is what actually showed as well. So if I actually show you, there's actually multiple options in here. There's like a open-ended question. It's like a prompt to ask like general questions on SAS or Python code. And then there's an overview thing. So it basically just gives you an overview for this particular code block. And then optimize, it gives like an optimization suggestions on how you can, maybe have it run faster, and suggestions on validation, and suggestions on conversion. So a quick note here, the Ask AI won't actually do the conversion or validation for you. It will only give you some suggestions. So for example, in validate, it'll just give you maybe like a few edge cases to test out to make sure it's running fine and things like that. So I can also use these options in here. So if I click on overview, it will start generating a response, and it will basically give you like an overview of what this particular block is doing. So as you can see, like this was pretty fast, and it was showing like it's a proc sort, and then it's using this data set, and we have this variable, and basically we are outputting a new data set and things like that. So this is pretty helpful, and it's for the users to basically help understand how things are going, if there's any confusion, or you can basically just copy this code and ask some detailed questions if the overview isn't enough, but these are a lot of options for the user to actually use. And let me now show you the code editor. So let's actually pick a file we haven't converted before. So let's do this. So in here, one of these options in here is the full code editor. So if I click on that, on the left side, you have the SAS code, and the right side says no PySpark code found. So that's because we need to convert the code first. And the way to convert it is actually one of these options at the top, convert file. And you're going to have a few options in here. There's PySpark, Pandas, Snowflake, Databricks, and things like that. So if I click on Databricks, and you'll see like basically a message at the top saying that the conversion has started, and usually it's going to be pretty fast. This is actually a really small code, so it should happen really fast. So the way to do this is like once you refresh this thing, the Databricks code should show up. And also, if you like convert it to multiple different formats, then you can use this to actually show like different formats. Like we haven't converted it to pandas yet, but this is an option to show like the required one you need. And you can actually modify the code in here and save it as well. Same goes for the SAS code, but the way to actually view it is finding it over here in Jupyter. I mentioned like in the output folder, there's going to be like this one. And if I go to demo score data, so let's actually go to default and then output. Yep, so this one says 57 minutes ago, seconds ago. So this is like the one we just converted. And then you can have the converted code as a Python script, which you can run as a whole, or you have like an option of having a Jupyter notebook and run it like block by block. And you can start running the code in here. Also, like like if your data is in Databricks, you will probably move the code to Databricks and basically start running in there. And as Ashley mentioned, it's basically good practice to use like a subset of your data set to run this first and make sure it's running completely before actually going ahead with the entire data set. And this one actually handles like I think tens of thousands of lines of code in seconds. So the conversion is going to be pretty instant. Most of the time you will be spending on is the validation stage trying to run this. So for a regular Python conversion, you can start running it in here. For PySpark code, you would need like a Spark cluster set up. But yeah, it's basically the same procedure. You just start running them. And also, like if I choose like a particular block in here, so these are all the blocks, it's basically going to highlight you like which that particular block is, and it's basically scrolling down to that block. So if I click on this, it'll scroll down to that, and it'll help you basically just compare the code in general. So this is about the converter, and this is pretty helpful to understand. And you can also go back to the lineage view, maybe try to understand the dependencies better and things like that. And this is the lineage for your code. And we also have different kinds of lineage. So there's like a data lineage. There's also project level and file level. So if I show you this one, so if I go to defaults, let's take demo score data. So this one is another lineage. So in the previous one, what we had is each node was a code block. This time, each node is going to be a data set, and the data set being used in this particular chosen file. And again, we can understand interdependencies on the data and how it's being created, whether it's being created using another data set that's already present and things like that. And you can do that for each file. And there's also an option for project levels. So if I go to default, this one is going to be like for project, but depending on how big your project is, you might have like something really large. Like you can see there's like a lots of arrows in here. So yeah, it's basically you have an option of doing it project level or file level, and it helps you understand like the data dependencies. We also have file dependencies in the workflow. So if I go to a file, let's say default score data. Okay, I think let's go back to demo. Okay, and yep, we have basically we have several files in, yeah, let's, okay, let's pick a different project. Yep, so it's basically going to show you different SAS files. So over here, each node is going to be a SAS file, and this time, like in this project, all of them are independent, so there are no arrows. But if you choose a different one, you can start seeing arrows. Okay, yep, I think we can regenerate. Okay, sorry, yeah, this is the one. So this one also has many independent files, but if we look here, we have a few examples where there are interdependencies between files. It could be that like the data set we're using in this particular file was created in one of these files, and then basically we output that particular data set, and that's being used as input in one of these files. So that's how the dependencies might work. Or it could be a code that was written in a previous file, and you're basically just executing it from this particular file. So this way you can understand the dependencies within SAS files of the project as well. And this one, so this is all covered in the analysis phase. So once you analyze your project, then all of these lineages should pop up, and then conversion is basically simple. You can go ahead and convert it in here. And once you've actually done the conversion, maybe you've executed some of your code, even generated output data sets, what you can do is you can start utilizing the data match feature. So a quick introduction about data match. So once you have generated your output, data match actually helps us compare it with the output from SAS. So basically, it's going to take two things as input. One is going to be the output data set you created using your converted Python script, and the other one is the output using your SAS script. And what it does is it actually like performs like a join of both the tables, and basically based on the join, it starts comparing each row and gives you like a report on how it's done. So over here, so if I choose a particular file, this will show you a lineage of the data set. So this is the same thing we saw in file level. The only difference is that we have an option of opening this thing and seeing reports. So once you actually generate an output and compare, the reports will show up in here, and you can import your reports as well if you generated it externally. So let me actually give you an example of how those reports look like. So I have this one open here, and this one's like sample report. It tells you like which script we are using, and then which table we are comparing for, and gives you like a check for the rows and columns. So this is how it shows up if it fails or something. And it gives you some summary, like how many rows were there in the SAS data set, how many of them were there in your converted data set, and the primary keys. So in order to actually perform the join on the tables, we use primary keys as unique identifiers to for like the code to know which rows to compare. And usually like you can use like one column or a combination of columns for a primary key. And that helps you like better actually know whether you're comparing the right rows in the data sets or not. And then we have column checks, which is how many of them are found in common, how many of them were there only in either data set. And there's going to be like a column match percentage. So for each column, it will show you what data type it is. and how many of them were matched, how many were a mismatch. So for this sample, we can see column 4 had like 78 mismatches and these many matches. So that's about like 99% match percentage. And when there's like mismatches, it will also show you like the top 5 mismatches. So you can actually see how it looks like and maybe make some inferences on what actually went wrong with the conversion. So we have the primary key. So this is going to be a combination of column 2 and 3 in here. So over here, ID 81 is column 2, 35 is column 3, and this one is showing like the column 4, what the result was in the SAS version of the output and what the result was in the Python version of the output. And sometimes these both could be the same thing. And the difference could be that sometimes like, the Python one has a different data type. So for example, if SAS had like a string called 14 and in Python it was like an integer 14, then it's going to give you like a mismatch. So this way you can actually find out like, okay, these are same, but it could be like this is the issue. So this helps us understand what the issue is, and you can go back and make some changes to the code, make some remediations to address that. And another kind of issue you can get into is like having duplicate primary keys. So these both are exactly the same. So that means your primary keys aren't exactly unique, and you probably need to use more columns in your primary keys list in order to actually in order for the code to know like which columns to actually compare. It could be that they're trying to compare this 14 with this 14 because it's like the exact same value here. So those are the kind of issues these report actually tells you, like you can go back and change them, or just keep track of what's going on. And if everything is converted fine and it's an exact match, you're done with your validation step, and then you can go ahead with the integration step to your target platform. So this is about data match, and this only works for tabular data. If there's any other kind of data, there would be like different kinds of tests you would need to perform. But I think the main issue is going to be with tabular data, because that's like the largest amount of data with millions of rows and things like that. So this one is a really important feature here for the validation step. And we also have log analysis. So every time like you run your code in here, you can generate logs, and they show up in here. So this gives you like a timestamp of when it was executed and the output it gives. And basically, like every time you run something, the logs show up in here. You can also modify the log directory. So you can change the log directory. So if you're working in an external platform, you can create like a folder for the logs and things like that. So you can keep them in one place. But you can also view them in here if you upload them. And there's also like an Ask AI for log sense, and even for data match, and for these lineages. So it's the same method, basically a prompt-based thing you can use for some additional help. So I think this is all for the brief demo of the tool. So I think we can go ahead with the questions.
I think we have time for a couple of questions. I know though too that the team has been answering in the chat as you were demoing, so that's good. So let me find a couple that they did not get to yet. Is there a timeline for when it will be rolled out? I'm currently doing a large quantity of SAS to Python coding manually and could really use something like this. I think there might have been a similar question later.
Yeah, I don't know that we have an exact date yet, but we are targeting the month of December.
I'm just taking some notes as we answer these. Okay, and then that one was answered. Sorry, our chat was also getting really, the replies were starting to get really heavy. So sorry if I missed this, but how does one access this tool? Is it built into Databricks?
So it's not built into Databricks, it's a separate tool. And so for what will be available in December, you would take your SAS code, upload it into the SAS2PY tool, do your conversion, take the converted code and download it, and then take that converted code over to the Databricks environment for execution.
Okay, thank you.
And
And then,
And maybe one quick addition to that. So once you have the converted code, there's no dependency on SAS2PY anymore, right? So SAS2PY is a conversion tool. You take your converted code and you can take that to whichever environment to execute the Python PySpark code, but there's no dependency on SAS2PY once the code has been converted.
thanks. Let's do one more before we go to our break. And then any others, I'll be sure to pass along to the team after we wrap up today to make sure they're getting answered as well. How does it handle outputting libname.dataname? Does it always output to the project schema?
So I'm going to defer. Suman, do you know the answer to that?
Yeah, if you have pads set, like directory pads and all that, it does try to resolve all that automatically. So if you do define a custom path and so on, and we try our best to translate that over to whatever local file system there is, it does resolve that, as far as I know.
Okay, thanks.
Okay, thanks.
So I think at this point we can go ahead and wrap up our 7th session for today. And then I do see we got a couple more questions coming in. Let me just make a quick jot down of those. And it looks like Parv was able to actually get those last ones that came in, but I want to make sure I make note of them so they can be published as well before we wrap. Okay, so thank you so much to our presenters and thank you to all of our attendees for attending session 7. We are going to be back for session 8 in just 8 minutes now. And session 8 today is Introduction to Data Best Practices. And so that will be happening at 3 o'clock. So make sure you join us after a short break here and we will see you then. Thank you so much, everyone.
Okay. Thanks, Julia. Thanks, everyone.
Thank you.